Pre-calculus, we are going into a new realm of exponentials and logs. This chapter did not end with logarithmic graphing, but it does take a pretty sharp turn. We're going back to solving equations, but now you're going to be given logarithms in the equation, and we're going to have to figure out a way to get rid of those logs. I'm also going to do a couple little calculator gymnastics skills with these two examples, just to A, make sure we understand all the rules of logs, and B, can we do stuff on the calculator that's a little bit more than just basic. So, first things first. If you're trying to do something with this logarithmic expression, recognize that there's this thing called the change of base formula. I touched on it way before Thanksgiving break. The change of base formula basically states that if you've got log base 4 of 17, your calculator only really processes two kinds of logs. It's a log with a base 10 and log with a base e. We haven't talked about that at all. We will talk about it shortly, though. The change of base formula basically says log base 4 of 17 is the same as log new base. In this case, I'm just going to use the calculator default setting of a base 10 of 17 divided by log base 4. So this is a way in which we can utilize our calculator. If there's no base given, that implies that it's log base 10. Okay? So 12 times this is the same as 12 times this. So it's going to be 12 over 1 times log base 10, 17 over log base 10 of 4. Yeah, so that essentially does the same thing when you've got log base 1/5 of 13. We're just going to turn it into the common log of 10. I'm not even going to write it. You don't write it, it's base 10. And that shouldn't be equals, that should be minus 7, so 7 over 1 times that new logarithmic expression. So, some takeaways. 1, you can change the base. This turns into that, and then it turns into a series of calculations that your calculator will do for you. Pause the video and see if you can do it without my assistance. All right, let's check it out. 12 divided by 1 times log 17 divided by log of 4. All right, that gives me 24.52. I'm going to round it up to 5. Subtracting, well, I'm just going to figure out what this expression is. 7 times the log of 13 divided by the log base 10 of 5. Oh, no, 1/5. Now, it's interesting. Here, I'm getting a negative 11.156, which I think makes sense right here, because log base 10 of 10 equals 1. So any number in between 0 and 10 is going to be a number that probably produces a number that's less than 0. Here. What I'm saying is it should make sense that this is negative. We could graph it to truly discern what's going on here. Log base 10 of x at 10 would equal 1. But at 1 equals 0. So what happens when I plug in something like a 1/5? Well, that's going to correspond to a negative value on the logs graph. Anyway, I'm going down a rabbit hole I don't really intend to with this video, so this should be approximately 35.618. You can do the same thing with this extra expression here. The 4/3 right there is an exponent. What I wanted you guys to understand from this particular case is if you've got an exponent in a log, it comes down and becomes, if it makes sense for the calculation given, it becomes the coefficient. So this right here, log base 5 of 4 to the 4/3 power is the same as 4/3 times log base 5 of 4. This power becomes the coefficient. And then this over here, oh man, it's kind of, there's stuff flying all over the place. What I would do is say 3 divided by 7 over 6. We can clean this up. 3 divided by 7 over 6 is the same as 3 over 1 times 6 over 7. I just did a keep change flip to divide those fractions. And this is the same as 18 over 7. You can manipulate the coefficients without having to mess with the logs themselves. Log base 4 of 13. Log base 17 of 9. So at this point, you'd use your change of base formula. Up here, it's probably going to be to your advantage to actually disconnect the numerator from the denominator and write out the division horizontally. I'm going to get rid of this stuff over here. It's in our way. Okay, so my numerator. My numerator is going to be 18, and then I'm going to do a change of base formula on log base 4 of 13. It's going to be times log now base 10 of 13 divided by log base 10 of 4. So all I did was deconstruct the numerator of this fraction. Then I'm just going to do straight division symbol here. 7 times log base 10 of 9. All right, so remember, it's not the bigger of the two numbers. It's always this part of the logarithm. Divided by log base 10 of 17. And then over here we would do plus 4/3 times log base 10 of 4. I can just put it in the fraction like this, divided by log base 10 of 5. All right, so if we did those calculations, who knew we'd spend so much time on calculator work in a YouTube video? 33.304 is my first part here. Second part. We get 5.429. So we figured this out, checked it off the list. Figured this out, checked it off the list. And then the top 4 times log of 4 divided by 3 times the log of 5 comes out to be, should be 1.148. Make sure you got, oh, by the way, interesting thing here. Sorry, you couldn't see that part for a while there. 4 log of 4 can be rewritten, if you wanted, as 4 to the 4th power. If that's easier for plugging into the calculator. I just happen to know that 4 to the 4th power is 256. So, I don't know. That makes it easier to check our work. Just like 3 log base 5, that 3 can go back to be the exponent. So it's log base 5 to the 3rd power. I just so happen to know that 5 to the 3rd power is 125. So this is a very easy way to check to see if you did that calculation properly. Log of 256 divided by log of 125, a lot easier to plug in the calculator. And it also ends up being 1.148. Nifty, huh? Yeah, okay. So 33.304 divided by, we got to do this. Order of operations says do that first. 5.429 plus 1.148. The whole thing ends up being 7.282. All right, so there's a few parts to this where I just wanted to get you guys more comfy with the calculator, doing the change of base formula, recognizing that these moves exist for logs, and hopefully you learned a few things from it. All right, I think it'd probably be good to start the video part 2 on this because I think we need a little bit of a palate cleanser from all this before we start doing actual solving equations.